next, we have Mohamed Kabiruddin, Senior Product Manager, all the way from US. Managing your own databases, who's got time for that? Mohamed will show us how Google Cloud SQL can simplify your life, boost performance, and let you focus on building awesome apps. Mohamed's expertise in cloud databases is unmatched, and his talk will leave you ready to take your projects to the next level. Let's all welcome Mohamed for his presentation, guys.
All right, I'll let everyone settle in. All right, I've got some swag to give away first. So a bunch of questions. Let's see who gets this. How many of you use Google Cloud or have used Google Cloud? Okay, can anyone name, okay, this is a tough crowd, maybe 7 Google Cloud services? All right, you go. No, I'll stop you right there. Go ahead.
ORAN, solutions, BigQuery, Postgres,
4, 3 more. You got one right here. Okay, 2 more. Okay. Sorry? All right. There you go. Okay, who here is has worked on databases or works on databases? Database developers in the house? Okay. What engines do you think we support in Cloud SQL? What database engines? Right? Sorry? There's 2 more. Okay, I need all 3. Does anyone know all the 3 database engines we support in Cloud SQL? Okay. Sure? 1 more? Yeah, that's right. Yes. All right, I'll let you share these 2. Okay, this should be easy. Which database do you think Gmail uses behind the scenes? Sorry? No. No. Yeah. No. Pretty popular. No. No. Yes. Spanner's answer. All right, now that we've got that out of the way, so I'm here to talk about supercharging your applications and databases with Cloud SQL. My name is Mohamed Kabiruddin. I'm a senior product manager at Google Cloud. My team builds Cloud SQL databases. I live in Seattle in the US. Got here Sunday night, still jet lagged, trying to get over it, trying to stay awake. So thanks for having me. And Geshan, thanks to accepting my my request to speak. I'm really surprised by the community here. I've been to many meetups. This is by far one of the largest communities, and good to see the activities here. So thank you. All right. A few things about me. Love working on databases. I've worked for databases for quite a while. I've done a lot of SQL Server in my past life. I used to work at Microsoft in the SQL Server team as well. Prior to working in Google Cloud, my role at Google was working in Google Search on their data platform, in the serving platform, serving their queries. I had a little bit of fun doing that. And then I came to Google Cloud because, again, databases was an exciting space to be. And now I work on Cloud SQL, which is Google's one of the popular database services that is used by many enterprises and customers around the world. So let me give you a snapshot of what databases are offered by Google Cloud to begin with, and then we can dive into Cloud SQL. So firstly, the thing that we focus on at Google Cloud is to make your lives easy as developers, as users of Google Cloud, so that you can innovate faster, you can build applications that really matter for your business, while leaving the management and database operational capabilities to Google. So we want to take the liberty to manage your databases, operationalize them, run the whole gamut while you focus on building your applications. With that in mind, we have a large variety of databases that you can choose from. So starting from the left-hand side of this diagram, where we offer third-party databases that are fully managed as a database service, to the right-hand side, which are Google native database platforms. So to begin with in-memory databases, we have Memory Store that offers Redis clusters and now open source Valkey. We run Oracle DB in Google Cloud. So if you're running Exadata type workloads on Oracle, you can bring them to Google Cloud and we run them on Google Cloud. Cloud SQL is a product I work on. So Cloud SQL supports MySQL, PostgreSQL, and Microsoft SQL Server as a fully managed database service. Alloy DB is a Postgres database that is half natively built by Google, which has fine-tuning performance for supercharging your applications, especially with Postgres databases. And it has native Google AI capabilities for vector search that gives you the power to build generative AI applications as well. Now, Alloy DB also has an interesting feature where you can take Alloy DB from the cloud and run it in your own data centers as Alloy DB Omni. Spanner is purpose-built for planet-scale applications like Gmail. Gmail was built on Spanner, and now we provide it as a service for customers that want to run planet-scale applications, especially for large businesses that has a global presence. Bigtable is a key value store for those applications that need a key value database. Bigtable is a good fit. Firestore is our document database. So if you have NoSQL type document database needs, Firestore is your go-to in Google Cloud. And BigQuery is a very popular choice for analytics, data warehousing, machine learning workloads. Underpinning all of these, you have various services that plug into the ecosystem. So if you want to migrate data into databases using database migration service, if you want to transfer and replicate data from one service to another, you can use DataStream. So there's a whole range of services that are very well integrated with our database ecosystem. Now I'm here to talk about Cloud SQL because that's what I focus on and that's where I spend a lot of time working on. So I'll talk you through what Cloud SQL is for those who are not aware. So Cloud SQL is a fully managed database service that runs MySQL, PostgreSQL, and SQL Server, depending on your application and database needs. It is used by more than 95% of Google's top 100 customers. It is fully managed and enterprise ready. So again, going back to my initial thought where you run your applications, you write your queries, leave the rest of the management to Google. That's where we come in and run Google Cloud SQL as a service. It is trusted and reliable from the ground up with all the security mechanisms built in, and I'll talk about that in a little bit. It is very developer friendly for all you guys who work on back-end, front-end platforms. It has a lot of capabilities that are very developer centric, and you'll appreciate why I say that. A lot of enterprise customers, startups, digital natives use Cloud SQL. It is one of the most popular database offerings within Google Cloud. So firstly, when you provision Cloud SQL databases, you get flexible configurations to choose from in terms of sizing, whether you want a lightweight database, whether you want a heavier database, whether you want a memory optimized database or a performance optimized database. You get a range of choices, machine shapes to choose from. And again, within any cloud provider, you get to choose the type of machines that you want to run to a certain extent. With Google Cloud, you get to pick the type of machine, but you can also pick the specifications for the machine depending on the CPU and memory needs. In terms of storage, you have SSD as a persistent disk option that is attached to the database service to run your database workloads. And we support up to 64 terabytes of storage for Cloud SQL. We have plans to increase that in the future, but for now we support 64 terabytes. Again, a lot of enterprises today don't necessarily exceed that limit. We have a few that always go above and beyond that, but 64 terabytes is still a large amount of storage space. In terms of IOPS, we offer up to 100,000 IOPS for Cloud SQL databases. Now, the provisioning experience itself is very simple. You go to the Cloud Console, you specify what database you want, and the provisioning kicks in. Within a few minutes, you have a database ready to go. The way you provision database is through multiple interfaces. Again, you can use a friendly UI, Cloud Console. You can use command line interfaces. You can use REST APIs. If you're familiar with Terraform, you can use Terraform. So you have a whole bunch of choices to use your interface of your choice. And obviously, the connections through to the databases are either private or public, depending on your networking infrastructure needs. Now, with databases, one of the biggest challenges that DBAs often face is, as databases push out updates, version upgrades, etc. How do you manage that? All of that happens in place within the database itself on Google Cloud. So all you have to tell the service is, I want this new version of the database, run the database upgrade in place without having to migrate your data elsewhere, thereby minimizing the impact to your application. So imagine you have SQL Server 2019 running in your environment on Google Cloud SQL, and you want to upgrade it to 2022. You can do that in place on the console. You can just select the version, say I want 2022, and all of that happens seamlessly behind the scenes while not disrupting your application. Again, all of this is centrally managed and logged. So all the audit operations, all the operational logs are captured within Google Cloud Console. You can monitor them yourselves. You can go to the console, have a look at it. You can even plug into your third-party monitoring solutions as well. Now, there's a common API for all these databases, and this is where Cloud SQL really shines in. Regardless of the database engine that you choose, whether it's MySQL, PostgreSQL, or SQL Server, you as a developer focus on the APIs or command line interfaces, and behind the scenes, the right databases are operationalized using our APIs. So, for example, if you write a command to provision the database pcloud SQL create, the same command is used across all the engines. So you don't have to learn the nuances of every single database. All that you need to understand is what command goes to create a database. Behind the scenes, we'll take care of doing all the plumbing for you and making sure that you get the right database based on the parameters and specifications that you provide. Again, I'll go through the interfaces in a later slide. But in terms of authentication and authorization, Google has its own identity and access management for databases. So you can use Google IAM to authenticate into your Cloud SQL databases. For SQL Server specifically, which is a Microsoft product, we run it as a fully managed service, and Microsoft products are very well compatible with Active Directory. So we offer our own managed Active Directory in Google Cloud that communicates with SQL Server. All right. So we've been running this service for a few years, and obviously as a product manager, we listen to constant feedback from customers, developers like yourself on what you need from a database. And these are the things that we've often heard from customers. Developers need better performing applications. You're constantly challenged with database bottlenecks that are either non-performant or have query performance bottlenecks. Business needs continuity in terms of having a robust database that never goes down, that is, that can deal with nuances of infrastructure, networking, security, etc. And obviously, performance improvements for your application is key to everything. So we invested in something called as Cloud SQL Enterprise Plus Edition, and we launched this a couple of years ago for our database engines. And what this means is we've invested in a bunch of features for performance and business continuity that will make your applications much faster and much smoother to run from a business perspective. So in terms of performance, we introduced new machine shapes. So again, if you think about databases as a fully managed service, you don't necessarily need to worry about what infrastructure is running under the hood. All you care about as a developer is to have an endpoint that your application can talk to and write queries into. So we manage the infrastructure under the hood, but you get the option and flexibility to choose the type of infrastructure that you need. So we've introduced two new machine families, performance optimized and memory optimized. When it comes to database workloads, either you choose a CPU-heavy machine or you choose a memory-heavy machine, depending on the workload. And again, I'll talk about why the difference in a second. In addition to the machines that you can choose, you also have an option to have a data cache attached to your database. Now, data caches, as developers, you would appreciate that they are great for boosting application queries, especially those that are very warm user queries and workloads that are constantly run frequently. So we've introduced a data cache that is attached to every single database in Enterprise Plus Edition. In terms of business continuity, we offer 4 nines of SLA, so 99.99% availability SLA, which means we are only down 0.1% of the time. Or rather, we guarantee 99.99% availability SLA for our databases. We've introduced advanced disaster recovery capabilities. Now, outages happen, things can go wrong, data centers can crash, can happen anywhere. That's not to say it has happened before, but in the case of an event where a data center or a region goes down within Google Cloud, with advanced disaster recovery, you can fail over a database from one region to another region very seamlessly, but also come back to your original primary in a switchback fashion without losing any data. So that's one of the features we've invested in to make sure that you can not only fail over, but also come back to your original region once it comes back online without losing any data. In addition to all of that, as an application developer, you don't have to change connection strings when you fail over a database from one region to another. It is transparent for you. That happens under the hood. You have a single write endpoint that your application will talk to, regardless of where the database is sitting. Let's say you have a database sitting in the Sydney region and another one in Melbourne. When the failover happens, you don't have to go and change your app config connection strings to point your database to Melbourne. That happens seamlessly through the single write endpoint. Now, as part of this Enterprise Plus edition, we measured performance improvements compared to our previous version of Cloud SQL. And we saw 3x faster read throughput for Postgres and MySQL. We saw 2x improvements in write throughput for Postgres and MySQL. And we saw 4x improved read performance for SQL Server. Again, if you have performance-sensitive applications and you're looking at Cloud SQL, you should look at Enterprise Plus because it gives you better machines, it gives you data cache, and all that contributes to better performance. So a little bit on the data cache. Data cache is essentially a locally attached SSD storage that is attached to every machine that runs the database service. Now, if you look on the right-hand side, these are the machine sizes that we offer. So you can start with 2 vCPUs all the way up to 128 vCPUs. Now, for each of these machines, we have a fixed cache size. And if you notice, the cache size is much larger than the memory size. So for the largest machine, we have 128 vCPUs with 864 gigs RAM. But the data cache that gets us attached to it is 9 terabytes. So imagine putting almost your entire database, which is probably 5 terabytes, let's say, for example, on cache and have your applications read from cache for every single query. That's going to boost your performance for the application. And that's what we measured with performance improvements on the service. Again, this is a very popular choice for our customers where data cache is giving them a lot of benefits in terms of performance. Now, I mentioned about the different types of machines. Now, with performance-optimized machines, you get 8 gigs of RAM per vCPU. This is important because when databases run your queries behind the scenes, every CPU cycle requires memory bandwidth and memory associated with it. Now, for very CPU-centered applications, which are typically your tier 1, tier 2 applications for most customers, performance optimized is the right machine size. For those workloads that have business intelligence, data warehousing, analytical processing workloads, those are very memory-centric workloads. They're not as much on the CPU side, but more heavier on the memory side. For those, you choose memory optimized, which gives you 32 gigs of RAM per every vCPU that you have on the machine. Again, this is for very large workloads. Typically, business intelligence data warehousing workloads are well suited for memory optimized. Okay, so that was a little bit on the Cloud SQL introduction, infrastructure options, and what you get out of the box. As a developer, what are the things that matter to you? Firstly, query performance troubleshooting. When you come to cloud services like Cloud SQL, you want to make sure that you get troubleshooting as seamlessly as possible so that you don't have to go digging into the details. We provide query insights and system insights out of the box for every single Cloud SQL database, where you can look at things like weight statistics for a query and understand and analyze what's going on and where the bottleneck is. You can also use system insights to track your system utilization, whether it's CPU, disk I/O, memory utilization, to just figure out where the proactive bottlenecks are. And maybe as a IT administrator, you can have proactive alerts going out to your teams to monitor that. All of this comes out of the box with Cloud SQL. You don't have to go write queries to figure out what, to extract this information. Typically for users of SQL Server who are familiar with SQL Server, you would write DMV queries, or you'd run query store. You'd write a bunch of complex queries, analyze that data. It's pretty much a 3-4 day job to sit and do that work. This comes out of the box for you. And this has history maintained so that you can look at historical past and see where your queries are trending over time and figure out where the bottlenecks are. And again, if you've made application changes, you can track the query performance through Query Insights and see how that has impacted your query performance. The next feature that you'll appreciate is something called as Database Center. So this is a product that Google Cloud runs that automates fleet management across all databases. So if you're a company that runs, let's say, 100 databases or even a dozen databases, and you want to monitor them all in a single pane of glass, you want to have a look at all the security alerts for the databases, you want to look at performance issues for all databases, you want to look at networking constraints on all databases, you can do that in a single pane of glass with Database Center. And this has intelligent recommendations built in with AI and Gemini capabilities to give you proactive alerts on where things might be going wrong. Like, for example, if you have a database that doesn't have audit turned on, and if a malicious actor has come into your database, it'll give you proactive recommendations saying that this particular database doesn't have an audit log turned on. Please go turn it on. So this is very useful, again, if you have a large fleet of databases that you want to monitor. Now, I'll get into Gen AI a little bit later, but one of the popular data applications within Google Cloud is Firebase. Anyone use Firebase here? So Firebase is a very popular web and mobile application interface. It has SDKs. It has a low-code, no-code platform built in to build your applications. Think of it like a self-driving application platform that's built with all the bells and whistles. Now, Firebase has something called as Data Connect, where it'll automatically provision a database behind the scenes for you, and that is using Cloud SQL under the hood. So as an application developer, you can come to Firebase, build a mobile application, tell it that you need a database behind the scenes that you can write queries against and retrieve data from. And all that happens seamlessly to Firebase Data Connect, where it communicates to PostgreSQL behind the scenes. Firebase application converts your application code into SQL queries and transacts with the database. Again, a very popular choice for a lot of application developers who use Firebase. I'll talk about the vector support in later slides. Again, as database developers or developers of applications in general, you'll be seeing an uptick in a lot of your businesses and customers starting to use Gen AI applications, both from third-party services, but also wanting to build in-house Gen AI applications for your business. And I'll talk about how Cloud SQL can help there. Okay, so in terms of interfaces, we all love interfaces as developers. You live in a world of using tools and components and studios where you write code, you debug, you troubleshoot. But for databases, we have something called as Cloud SQL Studio for Cloud SQL, where you interact with databases, you look at schemas, you look at tables, views, procedures, functions, but you also write queries, you manipulate results, you analyze data. As a business analyst, you can go and write queries using Cloud SQL Studio. Now, what we've done with Cloud SQL Studio is Google runs Gemini as an AI agent. So under the hood, you can write natural language prompts out of the box on Cloud SQL Studio. So if you're a database developer that is new to writing SQL queries, or you're an application developer that focuses on building applications but not necessarily writing the best SQL queries, you can tell Cloud SQL Studio to write a query for you, and it'll go understand the schema in your database. It'll go understand the metadata of your tables to write a valid query for you. And those queries understand the context of your database. We don't read your data. We don't have access to your data, but we have access to your metadata, which is your table data types, your table schema, the views, your functions, and so on. So again, very useful for application developers who are getting started, who don't want to deal with writing complex SQL queries. I mean, I wrote SQL queries for 10 years of my life. I feel useless now with Cloud SQL Studio. The moment this came out, I wrote a natural language prompt. It wrote a SQL query that was like 50 lines long with nested queries, common table expressions that I would only could dream of in my past life. Again, a very popular choice for application developers. All of this is through the web interface. So when you access Google Cloud Console, you get access to Cloud SQL Studio free out of the box. You don't have to install or set up anything on your desktop to access this. Okay. The next thing I want to talk about is infrastructure as code. So again, as infrastructure people, developers, you're constantly challenged in automating a lot of your processes. As much as we love working with UI elements, there's a lot of push towards automation, making things more programmatic, and having databases do their operations more programmatically. So we have a range of options to suit your needs. So we support Terraform, we support Google Cloud's G-Cloud CLI, which is a command line interface. We also have Config Connector, which is an open source Google native Kubernetes configuration that you can use to configure databases. And Pulumi is a new one that is gaining a lot of popularity with open source developers, where you can write infrastructure as code to manage cloud services across different clouds. So we support all of them for you to provision databases, operate, configure, and manage your databases. Generative AI. Who builds Gen AI applications here or have built Gen AI applications? Okay. Can you give me an example of what you did?
For compliance, so compliance in the banks, they have multiple compliance documents, and it uses RAG to basically help new employees to see what the rules are.
Amazing. Yeah, so LLMs have spawned everywhere. Everyone uses ChatGPT, Gemini, and whatnot. But LLMs have a problem, as we all know. They hallucinate. They are pre-trained on existential data from the open source internet. They don't have access to your company's protected information or protected data sets. This is where we believe that databases bridge the gap between LLMs and Gen AI apps. So if your business is building generative AI applications and you're just consuming a pre-trained model, expect hallucinations, expect non-contextual responses because it doesn't have the full understanding of your company's business data. Databases hold that data, whether it's your CRM applications or ERP applications or HR systems. Like if you ask an LLM, if you're a HR person in your organization and you ask an LLM on, whether I should rate this candidate a higher performance rating, for example, it would have no clue, or it will just hallucinate based on, some random Reddit post that someone commented about, right? Whereas if you were to give it data set from your Workday or from your HR systems, it'll have better context in giving you better responses. So this is where databases come in. Now, to what this gentleman said, he built a RAG workflow, and RAG, which is retrieval augmented generation, is a very popular workflow that is used by many applications and enterprises these days, where a lot of developers are building RAG workflows, injecting it with databases, data sets from your databases. Now, the key to understand with RAG workflows is when you have LLMs that are pre-trained, LLMs are great at forming responses. Obviously, LLMs predict the next word, the next letter, grammatically accurate responses, and so on. But giving them context is even more important than getting a grammatically perfect response. So what RAG does is it injects your company's database context into the pipeline before it goes to the LLM to give it a response. So what you do in this case is basically you have a data set sitting in your database, you convert those to vector embeddings that have semantic understanding of your data. And using those vector embeddings, you're able to generate appropriate context that can feed into the LLM that will then frame the response from that context. So instead of cooking it from thin air or from a random pre-trained data set, it is using the generated embeddings that you've retrieved from your own database to give it the appropriate context. So these are gaining a lot of popularity. Again, RAG is one approach to building a Gen AI application. There's multiple ways of building Gen AI applications. Sometimes, customers and developers pre-train LLMs to death. You can do fine-tuning on LLMs itself without having to provided context. Now, for things like Gemini, you can provide a context window of like 1 million tokens. So imagine giving a full, 100-pager legal document or a compliance document to Gemini and getting responses. That's still contextual data, which is going to be generated from your own company's legal document. But again, that is fine-tuning it at the LLM level and not at the RAG level. So again, depending on your use case, you will use the right approach, but RAGs have gained a lot of momentum within companies because it has the most appropriate data set for your business needs. Now, LangChain is one of those open source orchestration frameworks that makes the RAG pipeline and the orchestration much more seamless. So for developers who are starting out, if you go and search for LangChain, it is an open source orchestration framework that helps you step-by-step build these RAG workflows with a vector store. So now you'll have to understand, you have a bunch of data sets sitting in your company's environment. Those have to be ingested into a database as a vector store, converted to embeddings so that they have semantic understanding that can be retrieved. Now, on the retrieval side, this semantic understanding plays a role because when the user queries something, those queries are converted to their own vector embeddings that are in close proximity to the responses and are given the appropriate results. So what you do with LangChain is you have three things that LangChain supports. You have a vector store, which basically stores your documents and retrieves them when you need to search them. You also have document loaders and savers. So these are things where when every time your RAG workflow needs to load a document, let's say a PDF document or an image document, into the whole workflow to retrieve it later, you need something that orchestrates the process. And again, LangChain supports it. And lastly, when you have your front-end application or an agent or a chatbot interacting with your models, you need to have the ability to have the memory of the conversation, because without having the contextual understanding of the whole conversation, it's impossible to give an accurate or contextual response. Now, you could ask me where I am in a chatbot, and I'd say, and the chatbot would answer, I'm in Sydney right now. And then 2 days later, I come back and ask the chatbot, hey, tell me recommendations for a coffee shop. It's probably going to give me a recommendation for a coffee shop somewhere randomly, like in Seattle in the US. If it doesn't have the memory that I asked it where I was 2 days ago and that I'm in Sydney, right? So again, having that memory for your AI agent is super important to have the contextual response framed in an appropriate manner. And LangChain, again, helps you orchestrate that. So for all these three operations, under the hood, Cloud SQL is supported as a vector store where you can natively convert your data set into vector embeddings that are supported by these frameworks to build your generative AI applications. Now, again, as an application developer, all you need to do is consume this LangChain framework using a language of your choice like Python, interact with the LangChain orchestration framework. Under the hood, vector store, Cloud SQL does its job in managing and maintaining and storing your vectors. There's a lot of vector embedding models out there that you can use to convert the data sets from raw documents to vectors. Now, to make this all seamless, we've created a jumpstart solution where if you're starting off fresh and you want to understand how this whole thing works, you can go to that link. It's a playbook in GitHub that is neatly documented with steps that you need to run to build a Cloud SQL database with GKE or Cloud Run running your application and build a full end-to-end generative AI application. Again, we made it seamless for you, so and it's documented so that you can understand the flow and how to work with it. With that, I would thank you all for your time and open up for questions. Go ahead. Yep. Yeah, so that has become a very popular use case where a lot of companies have a ton of documents that they want to search on. And what they're doing is they're putting those documents into a data store like Cloud SQL and converting them to embeddings so that when you search using a search platform of your choice, or a search technology of your choice, you're able to get more semantically accurate results. Now, for those who are aware of semantic search, is a very powerful technology where it understands the meaning of your data and not just your token-based, exact keyword search. So again, if you think about the history of Google search was very token-based. So if you asked a question, it would strip out the question into words. It'll go and match every word against an index and then retrieve the results for you as a full text search. That is no longer the case because with vector embeddings, every single thing on the internet is converted to vector embeddings that you can search against, and you can get much more semantically appropriate results. So that's becoming a very popular choice. And again, tools like Cloud SQL allow you to do that. And there are companies out there building AI tools that make all of this much more seamless. So I'll give you an example with Google. There's a product called Notebook LM. So if you go search for Notebook LM, it is free to use for anyone out there. I'm not 100% sure if it is available in Australia yet, but give it a try. What it does is you upload a bunch of documents to it, and you can ask it any questions. Behind the scenes, it does the magic. It does the semantic search for you. And not just that, a feature that has become very popular with Notebook LM is you give it a bunch of documents, and it converts it to a podcast that is very entertaining, right? Like, for example, if I use this all the time where, as a product manager, my engineering team would write a report for a product issue, right? We call these typically postmortems in Google. So every time there's an issue or a challenge, we would write a full postmortem about the issue so that everyone understands what happened. Now, these can be a few pages long and it's pretty boring documents to read. So, I do this all the time where I upload these documents to Notebook LM and have it convert to an entertaining podcast that I can listen to while I'm driving back home after work. And it's very entertaining, by the way. It gets the context of the problem. It adds its own humor to it, and it makes it much more lively as a conversation. It's like two people talking to each other in a podcast. So there are two speakers who ask questions and have conversations flowing. Pretty cool feature. So people are building AI applications like that where it's becoming much more seamless to put documents and search for. And again, I think there was a question previously where like what happens to tech writers, right? Again, I think the value in still writing good documents stays, and it's very relevant in this world. The real power of AI and generative AI and vector search applications is to search on those things to make discovery of those documents much more seamless. Not the writing part, because writing still needs the contextual understanding of the problem. Like if there's an issue that happened in your environment or in the product or your business, someone with an understanding of the business, an engineer, a database administrator, an IT administrator, needs to fully understand the situation, write up a postmortem report or a document that can then be fed into an archive, into a repository that could be much more discoverable. So I think there's still a lot of relevance. I love working with tech writers because, everything that's documented is information for the future. So a very useful way to think about it.
My question was, let's say, with the writing, if 5 people need to write a writing, can we cut to 2 people using the AIs? We can hire only 2 people. 3 people can be laid off using, there's 2 people with good. They can use the AI to enhance their performance. We don't need more 3 people to do the work. So if it does, so that the other 3 people hamper in their work, since we're having a lot of layoffs.
Yeah.
Like AI could eventually part of some of the people's work. The people who can use AI like good, they can do better than like combined people working together.
Yeah, I don't want to be an AI futurist and say the wrong thing because this is recorded, I believe. But I'll tell you a day in my life, right? So before the whole explosion of LLMs and AI agents, I typically spend days writing product documents, right? As a product manager, we write product requirements, we work with engineers, write design docs, review design docs. Now, that time of writing product documentation and reviewing documentation is significantly reduced. Now, that doesn't mean I've lost my job or my colleagues have lost their jobs, But what that has led to is faster shipping time of our product features, better product enablement, faster time to market, right? So the rate at which we are able to deliver things to the market and our productivity has increased, not the other way around where you've lost your jobs. I think it is actually working in the right direction to boost productivity. So I mean, I use Gemini on Google Docs if I'm stuck for ideas to get started. Use it as a starting point to understand certain talking points and framework, and then add my own flavor to it, right? But again, it helps my productivity. It gets through my day faster. I have much more time to focus on other things that really matter, and not sit and format documents and create bullet points that are neatly formatted, because all that is done automatically for me. Right? So I think yeah, again, not talking as a futurist, but what I'm seeing day to day is it's enhancing productivity, and we're able to do much better things. Any questions on databases, Cloud SQL, Google Cloud? Yep.
It's like 99%. So as a layman, I sort of wanted to understand how you guys do the conclusion of the metrics, like what sort of disaster recovery simulations, I guess, like, yeah, what sort of testings and disaster recovery simulations do you propose to simulate, say, a critical scenario that would be like, of high severity? So yeah, any insights on that?
Yeah, I mean, for a cloud service at that scale, where we have thousands of customers running, hundreds and thousands of databases, all of this is fully automated, right? So again, under the hood, everything is automated, fully tested. When we ship features, regression tested for backward issues and so on. But I think the most important thing there is when you ship a new feature, it is important to obviously automate as much as you can with your testing frameworks, so that you build up on it as time goes by, and not restart from or reinvent the wheel from where you left off, right? I think anything to help automate every single testing operation of yours is going to go a long way. Obviously, the SLA availability that we guarantee of 99.99% requires a ton of investment from the infrastructure, from the networking, from our jobs that run constantly. So again, for folks that are familiar with Google Cloud ecosystem, Google has this concept of Borg jobs that was used by Google Search. So again, when Google Search built its data centers, it ran Borg jobs, that hundreds and thousands of Borg jobs that run a lot of processes under the hood. So we use the same mechanisms to constantly run these things, probers to go and find out what's going on in the service, health probes that go and constantly hammer these services to detect violations, to detect any challenges. So all of that is fully automated. But again, to run a service that at that scale, it is absolutely critical that we do that. But you could start small by building as much automation as you can in every single code and feature that you ship out. How much time do you have?
Any more questions?
Thank you very much. Thank you. Thank you.